Hello all, welcome back to Engineering Economy. We were talking about the time value of money, and in this course we will learn about the cash flow diagrams. We will see the fundamental or basic notation that we will use in engineering economic calculations, and we will learn the fundamental law of engineering economy, which relates a future value of money to the present value of money. So let's get started. So what we have learned until now, we learned that money has a time value, and this time value is due to two facts. One is it has a time value because of the change in its purchasing power. So this year or today, your amount of money, the money that you have, has a purchasing power that you can measure in terms of the items or goods or services that you can buy with that money. And as the time passes, 1 year from now, 2 years from now, with the same amount of money, you can buy a different amount from these goods, and usually the amount that you can buy decreases due to inflation. And because of this, we say that the money, the purchasing power of money drops as time elapses. Because of this, the money has a time value. And also it has, because of its earning power, the money has a time value. If you have some amount of money now, you can use it for investments, and then you can earn more money with that initial amount. So 1 year or 2 years from now, you will have more money because you earned money with your initial amount. And because of these two reasons, we say that money has a time value. Also, we learned that the interest is the measure of the time value of money. If your money earns 8% interest rate, so this 8% is the measure that we use for the time value of money. So usually for these money transactions, we have one borrower and a lender. And this interest is a cost for the borrower because you borrow some amount of money, for example, $100 now, and you pay it more with the addition of the interest. So it is a cost for the borrower. But on the other hand, from the viewpoint of the lender, it's an earning. So you lend money now for $100, and in 1 year you receive it back as $105 with a 5% interest rate. So this $5 additional is an earning for the lender. We also learned the concepts of simple and compound interest rates. So simple interest rate is used only in very restricted situations, and the idea behind simple interest rate is you earn interest only on the principal amount. Okay, so if you lend or borrow money for $100 for 3 years, let's say, each year the amount of interest that you will earn or you need to pay will be equal to the original amount, which is 100 times the interest rate. But in compound interest, you earn interest for the original amount, the principal amount, plus any additional interest earnings during the past years. Okay, and throughout this book, throughout this course, we will mostly deal with compound interest. In order to make calculations with compound interest or interest rates, we need to sketch the so-called cash flow diagrams. And for this reason, for these analyses to calculate the economic equivalence of the cash flows, we need some notation. And this notation will be identical throughout this course, throughout the book. We will always use the same notation. So we should learn this. What is I? I will be the interest rate. Okay? So it is the effective interest rate per interest period. We will talk about later on what is an interest period. We will talk maybe on what's an effective interest rate. But for now, what you should know is I is the interest rate. And when I say, for example, 5% interest rate, this 5% is the interest rate. And sometimes this interest is applied in 1 year, but sometimes the interest is applied for in 1 month, sometimes it's in 1 quarter. So the period that this interest becomes effective is called the interest period. N is the number of compounding periods or interest periods. For example, if we say if we have 5% annual interest rate, okay, and if we lend, let's say, if we lend money for 5 years, okay, or let me say for 10 years, okay, so this is annual, yearly interest rate, and we are lending or borrowing the money for 10 years, then it means that the number of interest periods is equal to 10. But sometimes the interest rate is not annual, but it's monthly. Okay, at each month you earn or you need to pay 5% interest. And if you borrow this money for 10 years, then the total number of interest periods will be, in 1 year you will have 12 months times 10 years, so it will be 120 periods. In this case, N will not be 10, but it will be 120. Okay, so this N is not the number of years, it is not the number of months, it's not the number of quarters, it is the number of interest periods. And it depends on this interest rate. If the interest rate is monthly, then you look at how many months do you have during the period of lending or borrowing. If the interest rate is quarterly, so quarter, in 1 year, there are 4 quarters, okay? 4 quarters. And if you borrow money, for example, for 3 years, and the total N will be 3 times 4, 12 quarters. In 3 years, we have 12 quarters. Okay, so depending on the interest period, we identify the number of total number of compounding periods or interest periods. So we can use these names interchangeably, the compounding periods and interest periods. P, on the other hand, represents the present amount, present sum of money, the money that you have at current time. It's the equivalent value of one or more cash flows at a reference point in time, which we call as the present. So later on we will do some analysis, but always we will have these cash flows starting usually by time 0. Time 0 means now. And for example, this 1, 2, 3, these are the periods. And these periods can be months or years, depending on the situation, it may change. But for example, if these are given as years, okay, so this one represents the end of year 1. So this is the year 1. This is month 1 of year 1, month 2, month 3, all 12 months. And this one here is the end of the year. Okay, and similarly, we have the first month of the second year, second month of the second year, and we have the second year. And when we say this present amount, okay, so it is the amount now that we pay or borrow. But don't be confused. Sometimes we will have such cash flows. We will be currently at time 0, and then we will consider a cash flow at this time. We will find an equivalent cash flow, for example, at the end of year 2, that we know the amount in year 4 is, let's say, $100. Okay, so this $100 will be at the end of year 4, and we want to calculate the equivalent amount of this $100 at the end of year 2. So this year 4, if this is the reference point, okay, not 0. This will be the reference point, and year 4 is the future point. So somehow we will find the future present value of this future amount. Okay, so we will represent this as P. So from this sense, P does not mean the amount of money at time 0. It's not always the amount of money that we have now. Okay, it can be the amount of money at a future time, but we can select it as our reference point, and we can represent it with P being the present amount. And F is the future sum of money, and it's the equivalent value of one or more cash flows at a reference point in time, the future. Okay, so this F, similar to P, will represent a future time. We will make a lot of examples concerning these issues, so don't be confused at this time. These are just the notations. Just you need to know I is the interest rate, N is the number of interest periods, P is the present amount of money, F is the future amount of money, and what else? A is called the annuity. Okay, that's why it is written as A. So this is P because it comes from present value. Okay, so this P comes from present. This F comes from future, and this A comes from annuity. Okay. What does it mean? If there is a uniform series of payments or cash flows continuing for a certain number of periods, it will be named as the annuity. For example, you borrowed some money now at this time 0. So since you borrowed, the amount in your pocket is increased. So we represent it as a positive cash flow. You received this money. Let's say you received $1,000 now. And you are going to pay this $1,000 in 1 year, but at each month you will pay the same amount. So at the end of month 1, you will pay a certain amount. At the end of month 2, you will pay the same amount, and you will continue to make these payments until the end of the 12th month. And all these amounts that you are paying at each month will be equal to each other. So we will represent this cash flow in this way and name these equal amounts to be A. And we will find formulas how to find this A. So what amount you should pay at each month so that at the end of the 12th month you close up your amount, principal amount, which is 1,000, the amount that you borrowed. But of course, we assume that there is an % interest rate monthly. So it means that you will not only pay this $1,000, but you will also pay all the amount of interest that occurs during this time. Okay, so these are the basic notations: I, N, P, F, and A. This is a cash flow diagram, an example of a cash flow diagram. It is one of the tools that we will use too much in this course, and we use cash flow diagrams for clarifying and visualizing a series of cash flows. Okay, so this is an example. As I told you, this line is the time axis. Okay, time represents time, and in some cases this time represents months, sometimes it is years, sometimes it is quarters, and etc. In this example it is the months. So this is the end of first month, and this period over here is the month itself. So this is month 1 actually, and the end of month 1 is represented as a point on this time axis. So this is month 2 and this is the end of month 2. End of month 2 is the beginning of month 3. Month 3 starts here and ends here. So in this example, the total number of interest periods, interest is given as 1% per month. So the interest period is month. And we are considering 4 months, which means that there are 4 interest periods in this example. And what does this show? This P, $17,000, okay, at the beginning, this one. As you can see, the arrow goes down, okay? What does it mean? It means that we are paying this amount. So this money is reduced from our account, from our pocket. Maybe we lended this money to the bank. Now it is in the bank, so it is not with us now. It is with the bank, so this money is reduced from my pocket. Therefore, this arrow goes down. And after 4 months, what do? I earn 1% interest rate per each month, and at the end of the 4th month, I withdraw this money from the bank account. Okay, since I withdraw the money from the bank, the amount in my pocket increases. So I receive this money, therefore it's an upward arrow. And how much do I receive? How much do I earn? This much. How did we calculate this value? We will learn in a few minutes how we calculate it. But it is the result of this initial amount that we paid, that we deposited into this bank account, and the interest rate and the number of periods. Okay? By using these values, we will calculate how much we can withdraw at the end of the 4th month. So this cash flow diagram simply shows the amount of cash flow either we receive or we pay during all the periods of this time horizon. Okay, so this is just another example. It shows that I is at 10% per year, and now as you can see, these cash flow is represented in terms of years. So we have year 1, year 2, year 3, 4, and 5. In total, we have 5 cash flows. Okay, so this line here is the time scale that shows the time. From left to right, these numbers represent the time periods, and it can be years, months, quarters, and etc. Okay, this 2 over here, this value over here is the present value, and as you can see, it's a downward arrow, which means that we made this payment, so the money is reduced from our pocket. It's an expense for us, and it's a cash outflow. We will say it's an outflow, and when it's an outflow, we will represent it with a downward arrow. So we are now the lender. Okay. And for 5 years, we will receive an equal amount of money. So we deposit, for example, this amount to a bank account, and for 5 years, we will withdraw money, an equal amount of money from the bank account. And that equal amount, which is called annual income or annuity, will be represented by A. And as you can see, at the end of 1st year, 2nd year, 3rd, 4th, and 5th years, we are earning some money. We are receiving this amount. It's a cash inflow. That's why the arrows are upward arrows. And as I told you, we will learn how to calculate this amount. If we deposit this amount to the bank with a 10% interest year for 5 years, and we want to receive this equal amount of money for each year, we will learn how to calculate this value. Okay? This I over here represents the interest rate of the loan, and for the interest rate, it is represented like this way. 10%, 5%, 3%, but another important component is the interest period. Is it per year, per month, and etc.? We need to know that as well. And if in some questions, in some cash flows, we have such dashed lines, usually we will indicate the amount that we need to determine, we want to determine by such a dashed arrow. Okay, so it will be the question. We are given such a present value, such annual incomes. What will be the future value, future equivalent value of this cash flow? So this will be the question. We said that these cash flow diagrams are represented in terms of periods. So I'm not saying it is years, I'm not saying it is months, I'm saying it's periods, because from one question to another, one cash flow to another, it may be different. So that's why we are saying this is a period. And this 0 over here represents the beginning of the period, and 1 is the end of the first period. So if the cash flow diagram is given with respect to years, then this is the beginning of the year, which means that it is the 1st of January of the year. And this point over here is the end of the first year and beginning of the second year, which means it is the 31st of December and also 1st of January. Okay, this time represents the end of the year. And as I told you, the interest is usually given, for example, like this, 5% per year. Now this per year says that you will earn this interest. If you deposit this amount to the bank, you will earn this interest at the end of the first year. Assume that you withdraw some money from the bank account after the second month. Then you withdraw some amount in the third month. You withdraw some money again 5th month, 6th month, 7th month, and etc. during the year. But the year is not completed yet. These are the months, okay? Let's say. So the year is not completed yet, but the interest is given in terms of years. So it means that for this amount, for this amount, for this amount, you will not earn any interest. You will earn interest at the end of the interest period. So any amount that you withdraw or deposit in this cash flow that is in between the interest periods, so interest period is this one, anything in between, we will not consider it in these cash flows at the time of the transactions occur, but we will move all of these to the end of the period. So instead of saying that $10 withdrawn at the end of month 2, $8 at the end of month 3, and etc., we will not say that, but we will add them up, and which will give us $45, and we will say that all these $45 are withdrawn from the bank account at the end of the first year. Okay? Of course, this is the case when the interest rate is given per year. If it was per month, okay, and these transactions occur at month 2, 3, and etc., so we are not moving them now because we need to represent the time axis in terms of the interest period, which is months. But if this interest rate is given in terms of month and the cash flow diagram again is in terms of month, but now if the transactions occur within the days of this month, so for example, the second day, the third day, the fourth day. Okay, now this represents 1 month because the interest occurs each month, and we have some transactions within the month. Again, then we need to combine them or convert them to the end of the period. Okay, what you should understand here is any transactions that occur in between two interest periods are collected and combined at the end of the interest period. And we will not see any such transactions on the cash flow diagrams in between the interest periods. Now, an important concept. This is the starting point, and we will derive a very important formula. And what is this formula? We will relate the present and future values. So what does it mean? For example, if in this cash flow, let this 0 represent the current time and 1 represents the, let's say, end of the first year, start of the second year. So this represents 1 year. And assume that there is 5% interest. So we can deposit some amount into a bank, and at the end of the first year, assume that we will earn 5% interest rate. Then the question is, how much will you earn at the end of the period? How can we find it? Since we deposit this money, we can represent this problem like this. Since we deposit, let's say $100 to the bank, we will represent it as a cash outflow. The money is owned by us. It's our money and it's in our bank account. But the thing is, the money is reduced from our pocket. Now it is in the bank. So we paid this money to the bank. That's why we assume this to be a cash outflow. And what will happen? It will stay in this bank account for 1 year, and at the end of the year, we will withdraw this amount. Okay? We will withdraw this money, but the question is, how much shall we withdraw? So I am going to denote this with a dashed line, and since this is a future value after 1 year, so I will denote it as F, and we want to find this future value. What should be this future value? Okay, how can we find it? And with this given information, $100 and 5% interest rate, simply we will own this. We will withdraw this $100, which was the original amount, the principal amount, plus we will earn the interest rate. And what is the interest rate? It is 5%. So 5% of $100. So it will be, when I combine them in 100 parentheses, 1 plus 0.05. Okay, this is the amount that we will earn after 1 year. Okay, so if you look at this, if n is 1, the interest period is 1, the future amount that you are going to earn in 1 year, so this represents for how many years into the future. Sometimes we will represent in this way. It will be the amount, the principal amount, multiplied by 1 plus I. Look, this is P, principal amount, multiplied by 1 plus I. And as you can see, if interest is 5%, in this calculation, we write it as 0.05. If it is, for example, 50%, we will write it as 0.5. Okay, so this is how we do the calculation. Now let me change the question a little bit and say that, okay, we deposit this amount to the bank, and after 1 year we don't withdraw it, but we will withdraw it after 2 years. Then what will be the future amount when we withdraw it after 2 years? So now, how can we calculate this amount? At the end of the first year, let me clear this part. At the end of the first year, we will have this amount. But then, for this amount, we will earn an additional 5% interest, right? So the amount of interest, so this amount is 100 times 1 plus 0.05. This is the amount that we own after the first year. Then, for this amount, we will earn an interest of this amount, okay, for the second year. This is the interest that we will earn for the second year. But at the beginning of the second year, what amount do I have? I have 100 times 1 plus 0.05, and then I will earn an interest for this amount, okay, for this much. This is the interest that we are going to earn in the second year. And if you look at this amount and this amount are the same, so if we collect under the same parenthesis, it will be 1. So from here I have 1 plus, from this part I have 0.05, 0.05. And now if you look at this part, they are the same. It means that the amount of money that I have at the end of the second year will be squared. So this amount is the principal amount, this amount is I, and this is N, the number of periods. So when N is equal to 2, the future amount that we will earn at the end of year 2 will be the future amount that we have at the end of year 1 plus this interest rate. And when we write this F1 as P times 1 plus I, like this, we will obtain this P times 1 plus I square. And if you continue in this way for the third year, fifth year, and etc., and if you have in total n years, now you can easily say that the future amount that you will have at the end of n years will be equal to this principal amount multiplied by 1 plus I to the power n. This is the fundamental law of engineering economy. It's very important. You can calculate all other formulas from this. Okay? We know in physics that, for example, force is equal to the mass times acceleration. This is some fundamental law in physics. Okay? Or the voltage is equal to the current times the resistance. Okay, this is another fundamental law in circuits, and we know that energy is equal to mass times speed of the light square. This is another fundamental law of physics, and in engineering economy this is the fundamental law. This is very important. Okay, this is the interest formula, of course, for compound interest, okay? Not for simple interest, but compound interest. So if you want to find the future value, given a present value with an interest rate and with a number of interest periods, we use this formula. Okay, a practice problem to understand this concept better. Assume that if we deposit $100 now, so when it is said now, it means that the time 0, okay, and $200 2 years from now. Okay, now in order to visualize and in order to represent this, it is better to sketch the cash flow diagram. Okay, the cash flow diagram is very important, and it means that according to this deposit amount which occurs at time 0, so we need this time 0, then this is the end of year 1, this is the end of year 2, and it says that we deposit. Depositing to a bank account means that this money is reduced from our pocket. It's a cash outflow. Then we need to represent it as a downward arrow. Okay, so this is $100. And it says that this $200 is 2 years from now. So this is 1 year, this is the second year, and it appears at the end of the second year. Okay, and look, the length of the arrows usually represent the amount of money. So if you represent this $100 with such a length of the arrow, then in the amount $200 should be longer than that one. Okay, So this will be helpful in visualizing the amounts of these transactions and etc. Okay, so these are the amounts that we deposit into the bank account, and it says that there's 10% interest rate. So let me write this 10% here. And then it says that how much would you have at the end of year 10? Okay, now it means that I need to extend this cash flow until year 10. So we will have year 3, 4, 5, all the way up to year 10. And the question says that after 10 years, if you want to withdraw this money from the bank account, how much will you get? So if you withdraw this amount, it means that this will be a cash inflow for you. The money will come from the bank account into your pocket. And since we want to find a value in the future, we will represent it by F. And the question will be this. Okay, so this is the cash flow diagram. And when you sketch the cash flow diagram, actually, the solution, the answer is easy. But be careful. Look, we are depositing this $100 now and this $200 2 years from now. You cannot say that, okay, in total, I deposited $300. It is not correct because you are depositing these amounts at different times. You can just simply add them. They are different things now. They are apples and oranges. So any amount of money, any amount of transaction that occurs at different times on the time axis cannot be directly summed up. You need to first bring them to the same time spot, and then you can add. So how can we find this F then? The answer is easy. You can think about these transactions separately. What you can find is, okay, if I only deposited this amount, 100 at year 0, what is the value of it at time 10? Okay, forget about this one. Just consider the first one. And how much will you obtain at the end of year 10? And remember, the fundamental formula is P times 1 plus I to the power n. We will just use this formula. What is the principal amount? It is 100. What is the interest rate in the question? It said that the interest rate is 10%. So we will write 1 plus 0.1, 10%. And how many periods are there? You simply need to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Of course, you don't need to count because it already says that if you are going 10 years ahead, the number of periods, interest periods, will be 10. Okay, and when you calculate this amount, the value of $100 at time 0 will be equivalent to having $259 after 10 years. But this is only the first part of the question. Now there is a second part. And the second part is we also deposit another $200 at time 2. Now forget about this value. We will find the future value of these $200 that we deposit at time 2. But now you can be confused. Some students are confused at this point. They say that, okay, we are currently at time 0, and then we are depositing this $200 after 2 years, and then we want to calculate its equivalent value after 10 years. Okay, we don't know the formula for this. How can we calculate? It is very simple. We actually know the formula. You don't need to be confused here. Okay, when we are asked about finding the equivalent value of this amount that we deposit at time 2, and when we find its equivalent value at time 10, you just ignore this part, and you can say that, okay, let this be time 0. And if this is time 0, 1 year after this is time 1, then time 2, 3, 4, 5, 6, 7, and 8. So you can assume that the cash flow now is like this. We are depositing $200 at time 0, and we want to find its future worth, future equivalent at time 8. Okay, this is the same thing. But of course, I am writing this in order you to understand, because later on, after some time, when you get the idea, we will of course not convert these cash flows, but we will simply say that, okay, if this is time 2, this transaction occurs, and we want to find its equivalent at time 10, then how many periods are there here? It's simply 10 minus 2, 8 periods. So it means that, let me write this as F1, the future value of the first cash flow, and F2, let this be the future value of the second cash flow, okay, which is 200 times 1 plus the interest rate. Interest rate is constant all over the time. Now, the number of periods, it's not 10, but it's 8. Okay, we simply do the calculation in this way, and this value, we just calculate this one using your calculator, and then we obtain this value. Okay, so this is the second one, the equivalent value of this $200 in year 10, at the end of year 10. Now this amount is in year 10. This amount is also in year 10. Since they occur at the time, at the same time instance, we can just add them. And the total value is this much, okay, 688. Okay, so this is a very simple calculation. We just separately find the equivalent values of these two deposit amounts at time 10, at year 10. Okay, we convert this one to year 10 and this one to year 10 separately, and then add them up to find the final results. Of course, this is the first example, very first example. We will not spend this much time after this. This is just the first example. That's why I am explaining it in more detail. I want you to get the idea. But after you get the idea, we will not talk about how we do these calculations. We will just show this is the cash flow, and we will just say this is the final result. Okay, so you should be able to, you should be confident with these calculations, like using the mathematical operations, summation, multiplication, and etc. You should be able to do these calculations very confidently. And some of you may ask this question, okay, sir, this $100 that we deposit at time 0, what happens if we find its equivalent value at time 2? Okay. And then, since this, when we find its equivalent value, since that value will be at time 2, and this 200 is also at time 2, then we can add them, and then we can find their future value all together. Oh, good idea. Let's see if we can do it. So, let's first find the future value of this 100 in 2 periods. So, I will write F1 will be equal to $100. This is just a notation, F1, F2, F, and etc. So it's not important. Don't be confused. What does F1 means? What does F2 means? And etc. I'm writing that F1, and it's not that important. Okay, so F equals to 100 times 1 plus 0.1. This is the interest rate. But I am finding its equivalent value at the end of year 2. So this is just to the power 2. Okay, this will be the value of this $100 at the end of the second year. And this value is equal to $121. Now this $121 is in year 2. And it's still in the bank account. And we deposit an additional $200 into the bank account. Then what is the total amount in the bank account? It will be $321. Now, what do I have in this cash flow diagram? I have this. I don't have this part. I have $321 here, and I want to find its future value after 8 years. Okay, so how do I find this? F will be equal to $321, then 1 plus 0.1 to the power 8. Okay, so this value will be equal to $688, and as you can see, these two results are exactly the same, identical. So whichever you want to do, whichever you like, you can calculate this future value. Simply what we did in the first alternative, we separately moved these two deposits to year 10 and then add them up. And in the second alternative, what we did, we first moved this $100 to the second year, and then we added it with this additional $200, and then we moved this amount jointly to this future value at time 10, and both are correct calculations, and we obtained the same solution. Another question now. Consider the following sequence of deposits and withdrawals. Okay, there are a number of deposits and withdrawals over a period of 4 years. So we are depositing these amounts to a bank account. So now we deposit $1,000, and then after 1 year we deposit another $1,000. And then we withdraw at the end of second year, we withdraw this amount. And then we deposit another 1,500 in year 3, and then we want to withdraw the total amount in the bank account at the end of year 4, and we earn a 10% interest rate. So what will be the amount that we will withdraw at the end of year 4? So please pause the video at this point and try to solve this question by yourself, and after that look at the solution. Please pause it now. Okay, so I believe you worked on the question by yourself, and let's solve all together. How can we do it? Again, we can do this in different ways. We can do this separately, so we can find the equivalent value of this one to year 4, and this one at year 4, and this one at year 4. But the thing is, look, we should be careful. These blue ones, the downward arrows, they are the deposit amounts into the bank account, and this one is the withdrawal amount. So if the cash flows are in opposite directions, then you will not add them, you will subtract them. Okay, we are withdrawing this money from the bank account. It means that we need to subtract. And so we can find the equivalent values of all these transactions at year 4, and then we can make the final calculation by summing and subtracting the values. This is one way, but another way maybe is to be more careful about this and to do the calculation in this way. We first find the equivalent value of this $1,000 at this time, and then add it to this value, and then find their equivalent value in the bank account at this time. So here we are assuming that we are withdrawing $1,210, but the thing is, do we have $1,210 in the bank account at this time or not? If you don't have, how can you withdraw this amount? Of course, in this question, since we are withdrawing, it means that we have it. But let's see if we have it or not, and how to find it. So I'm going to calculate this $1,000, and what will it be in 1 year? So 1 plus 0.1, this is the interest rate, to the power 1. Okay, so it will be $1,100, this amount. And I am depositing another $1,000 to this. So it means that I will have $2,100 in year 1. And I will find its equivalent value at the end of year 2, which means that I will multiply this amount by 1 plus 0.1 to the power 1 again. So I am moving one step further. I am calculating its future value for one period. And this makes $2,310. So at this time period here, now, let me write with a different color. We have $2,310 in the bank account. And what we do, we withdraw this amount. So the net amount here will be 2,310 minus 1,210. Okay, it will be 1,100. Okay, and of course it is a downward arrow, the net amount, because this one is downward, it's larger than the cash inflow, so it will be a cash outflow. And now what can I do? I can represent the final or the current version now. This is time 0, this is time 1. At time 2, the net amount is $1,100. At time 3, the net amount is $1,500, and we want to find its future value of this. Okay, again you can continue in the same way. You can move this one period ahead and then add it with this 1,500 and then move it one period ahead and find the future equivalent as we did in the previous example. Or you can simply take this one to future and take this one to future and then add them up to find the future equivalent. So let's have a look at the solution. Okay, this 1,000, when we move it one period forward, find its future value 1 year after, it will be 1,100. Okay, because we multiply it by 1.1 to the power 1. And then together with this one, we have this amount. And its future equivalent will be 1.1 to the power 1 multiplied by this amount, which is this value. And now, as you can see, we are subtracting this amount because it is upward arrow. Okay, it is in the opposite direction. And then the net amount will be 1,500 at this point. And we move it one period further, meaning that we will multiply it by 1.1 to the power 1, and it will be this much. And we can add up this value because they are in the same direction. We have this net amount at the end of year 3, and we will multiply it by 1.1 to the power 1 to find its future value. Okay, this is the solution of the problem, and now you can be interested in this. If we calculate this value, we find the future equivalent values of all these transactions at the end of year 4. How? Separately. Move this to the year 4. So it is 1,000 times 1 plus 0.1 to the power 4. So we are moving 4 periods ahead. And then this one plus 1,000 1.1 to the power 3 because we have 1, 2, 3 periods now. And then for this one, I will move it forward for 2 periods, but since it's in the opposite direction, it will be negative. And negative 1,210, 1.1 to the power 2. And then this last one, it's again positive plus 1,500 multiplied by 1.1 to the power 1. And if you do this calculation, you will obtain exactly the same solution over here. Okay? You can do this calculation however you like. If you like, you can move them separately to the end of the period, or if you like, you can move them one by one and do the calculations at each period and then find the final solution. The advantage of doing this one by one will be this. Here you want to deposit this amount and you want to be sure that the amount in your bank account is satisfactory for that transaction, for that deposit. Okay, so if this amount was less than 1,210, if that amount was, for example, 1,000 in your bank account, then how can you withdraw this amount? It is not impossible. So in order to see this situation, you can move them one by one. But if you are sure that there will not be such a situation, then you can move them separately, like in this calculation over here, and find the future value. Okay, so we will continue our discussion on future present equivalent values and the time value of money in our next lecture. By the way, this is just a summary of the solution that we already calculated. Currently, at the current time, we deposit $1,000. Okay, we don't withdraw anything, and at the end of year one, this $1,000 earns an interest of 10%, and it becomes 1,100. We also make an additional $1,000 deposit, so the total amount will be the sum of these two. We don't have any withdrawals, so the total amount will be the sum. Then this amount will earn an interest of 10% until the end of the second year. So it will be this much, and we withdraw this amount from the total, and the net balance will be $1,100, and it will earn 10% interest for one period. And we also make an additional deposit of this much, so the total balance at the end of year 3 will be this much, and then this will earn an interest of 10% until the end of year 4, and there is no deposit or withdrawal, so the total amount at the end of year 4 will be this much. So we will continue in our next lecture.